Chapter 2, Lesson 5 of Geometry. We've been looking at congruent angles, and in this video we're going to now use those angle theorems and congruent angles that we've learned about in order to determine some equations and solve for variables. So you might be given a problem like this, and it says find the value of each variable. And like we've been talking about all year long, we need to look at the diagram and decide what we know about the diagram before we just start plugging values in and trying to determine stuff. Alright? Yeah, stuff. We try to determine stuff before we know what's going on. So we need to take a moment to look at what's going on. I have two lines that cross in number 1 here, so I know that these angles are vertical. And we just learned that vertical angles are congruent. So I'm thinking in my mind right now that vertical angles are congruent or equal to each other. So that means that this angle here and this angle here are equal. Now we've been talking about all year using a geometric equation first. Because these angles are not named or measured with anything, there's really nothing we can do other than to start with the geometric equation, or the the algebraic expressions given to us. So we'll go ahead and start with that because we don't have any markings. So we know then these angles are congruent because they're verticals. So I know that the angle that is measuring 3x on the left here is equal to this angle on the right, 80 minus x. Well, there's my equation. So now I can go ahead and solve this. So I'm going to add x to both sides. 4x is equal to 80, and then divide by 4, so x is going to be equal to 20. And I always look at the instructions to make sure I've done what they ask. Find the value of each variable. That's all they ask me, so I can reveal the answer actually is 20. Alright, so let's go ahead and take a look at this next one. Number 2 here, again, I have 3x and y here all together. Now again, I notice that these lines cross, so I know I have vertical angles, so I know that these angles here are equal. So I know that the 3x angle is going to equal to 75, so x is going to be 25. So I now know that x is 25, but now I have the y to take care of. And the y has a vertical angle, but there's nothing there, so there's no way for me to figure out or to determine the value of y using vertical angles. So now I have to think about something else I've done this year and see if I can't determine it that way. And I notice that, well, this angle here that's y and this angle that's 75 make a straight line, so I know that they can add together and equal 180. That's my angle addition postulate. So I can say y plus 75 is going to equal 180. I now have my equation with the variable y, so I can solve for that. So subtracting 75 from both sides, so my y variable is going to be a value of 105. So again, I review that. So x is 25 and y is 105. So you have to think about not only what we're working on right now, but remember the things we worked on in the past. You're going to continue to use those through the entire year, so you always want to think about going back and using those. Alright, let's look at some different types of example. Here's a proof, and this is we talked about a theorem shouldn't be used until it's proven, and here is a proof of the theorem 2-3 that they talked about. If it's complementary to the same angle, then they're congruent. So they've already written the paragraph for us, and they just left blanks, so all we have to do is determine what goes in the blanks. So angle 1 and 2 are complementary, which means what? Which means they add up to 90. And angle 3 and 2 are complementary, so 2 and 3 add up to 90 as well. And we're asked to prove that 1 and 3 are congruent. So by definition, complementary angles are two angles that add up to 90, so measure of angle 1 plus the measure of angle 2 is going to be 90. And also the measure of angle 3 and the measure of angle 2 is also going to be 90. Whoops, get that off there. So then we know that the measures of 1 and 2 are equal to each other because 90 is equal to 90. So we can use substitution again, where we take this 90 and instead of using 90 we use 3 and 2, because 3 and 2, or 3 added to 2, is equal to 90. So by substitution we can substitute that value in. Then subtracting 2 from each side, that leaves us the measure of angle 1 is equal to the measure of angle 3. So we have our proof. We've done what we decided to prove. All right. Name two pairs of congruent angles in each figure. So now you have to think about these angles that would be congruent and why. So here we have two lines that intersect, so we know the vertical angles are congruent. So we could say that angle DOB and angle AOC are congruent, and we know that because vertical angles are congruent. So angle DOB would be congruent to angle AOC. We also have this vertical angle here and here. You probably can't see that, that's yellow on yellow. But angle DOA, that's a D, excuse me, is also congruent, or would be congruent to its vertical, which is angle BOC. So vertical angles are congruent, so you could use either of those in the figure. Actually, it says the name two pairs, so those would be my two pairs, and they're both vertical angles of that. I want to take a look at these, and the key to doing these are kind of like word problems. A is twice as large as its complement, angle B. And what we need to do is we have to use the information that we're given in order to write an equation, because again, we can't determine the value of anything without an equation. So once we know what the equation is, or the equations are, we can solve for one of the angles. Now in a situation like this where you have two things that you don't know, we don't know A and we don't know B, from algebra we should remember that if we have two unknowns, we need two equations. Meaning, if I just simply write one equation with two variables in it, let's say y plus x is equal to 7, it is impossible for me to determine what the value of y is and what the value of x is because I have two variables in one equation. What I need is another equation that has a y or an x or both in it, and then using that I could then solve using substitution or elimination. So if I had another equation that said that x was 3, well then I could substitute the 3 in for x and determine the value of y. But I need to have this second equation. So in a situation like this, we have a statement here which we're going to translate from English into math, and that's going to give me an equation. It says here that angle A is an equal word, twice, that's 2 times something, twice as large as its complement, angle B. So angle A is twice angle B. Now I have two unknowns here. I don't know what A is, and I don't know what B is. So it's impossible for me to determine what A and what B is going to be mathematically without another equation. Now you may be able to figure that out in your head, but we want to write it out mathematically. So I need another equation. So is there any other information in the problem that helps me write another equation? Well, if we look here, this vocabulary word should help me. What does complement mean? Two angles that add up and equal 90. So I can say then that angle A plus angle B is equal to 90. So now I have two equations that have the same variables in it. So now notice that angle A is equal to 2 angle B's. I can substitute in for angle A. So 2 angle B's plus 1 angle B is equal to 90. So I used the first equation, the fact that A is equal to 2 B's, and I substituted in. Now I have an equation with just one variable in it, the angle B, so now I can determine the value. So 2 angle B's plus 1 angle B is 3 angle B's, and they add up to 90, or they equal 90, so dividing by 3, angle B is going to be 30 degrees. So angle B is 30. Now how do I figure out angle A? Well, it tells me right here, my first equation, that angle A is equal to 2 angle B's. So angle A is equal to 2 angle B's, which I now know is 30, so angle A is going to be 60 degrees. Alright, so that's how you would do that mathematically. And again, I'm sure some of you figured that out on your own in your head, but that's just getting the answer. And again, the idea behind geometry is that we can have reasons, and we can write equations, and we can get the answers and explain how we got the answer, not just because I figured it out in my head. Let's do one more. Let's do number 26 here. This is a little bit more complicated, but let's take a look at that one. So we're going to do the same thing. We're going to translate this from English into math. So it says that angle A is half as large. Let me get that here. So angle A is, that's an equal word, half as large as 2 times angle B. So angle A is half as large as twice its supplement. Okay, so again, I have two variables here, and I don't know what either one is. Okay, so I need another equation. Supplement means angle A plus angle B is going to equal 180. So now again, I have something here that I'm allowed to then substitute in. Now, you'll notice here I can simplify this because a half times 2 is angle A then is actually going to be equal to 1/2 of 2, which is 1, angle B. So again, now that I have this equation, I can substitute in, well, angle A is equal to angle B. So I can put angle B in here by substitution, giving me this equation. And now I can add two angle B's. So angle B is equal to 90, and because of this equation right here, angle A is equal to the same, angle A is also going to be 90 degrees. So when you're given a situation like this, you want to simply translate the statement into math sentences and then use the information to write equations, and then it's just a matter of algebraically doing substitution and solving for the value of the angle.